Let's take a look at number 4. The rules state the directions. Use a table to solve the equation and check your solution. Use a table to solve the equation and then check your solution. All right, so if we're going to use a table, we first must identify that we have two separate equations here. All right, this is one equation compared to another equation. So, therefore, we're going to do this. All right, we have x, y comparison. This is for our 4x. And then we have an x, y comparison. And this is for our 3x plus 1. Okay? Now, that means we need to use this as a working spot because we're going to be doing quite a few checks here. We're going to go with negative 1, 0, 1, and 2. Negative 1, 0, 1, and 2. Okay? All right, let's take a look first with 4x. 4x, if we change our x to a negative 1, our answer would be negative 4. If we change our answer to 0, our answer would be 0. If we change our x to a 1, our answer would be 4. And if we changed our x to a 2, our answer would be 8. Okay, there we are. All right, on the next one. If we have 3x plus 1, if our first answer is negative 1, if our x is negative 1, then we have negative 3 plus 1, give us a negative 2. If our x is 0, then this is 0 plus 1, so we have a 1. If our x is 1, this would be 3 plus 1, give us a 4. And if our x is 2, this would be 6 plus 1 would give us a 7. Okay, how long we need to do this? All right, we have a match here. I didn't see it at first, okay, but there's our match. All right, our match is 1. All right, so it asks us to check it. So let's check it. Let's plug 1 in, okay? We can check it by plugging in the 1, or we can check it by graphing it, okay? And so either way, we can check it that way, all right? So then let's take a look. Our textbook suggests that we can check it by graphing it, all right? That's what our checkbook suggests, okay? I'll be honest with you, I would not have enough time to table and check with the graph. So then we're just going to plug it in using the 1. So if we put a 1 here and a 1 here, we have 4 here is equal to 3 plus 1 is 4. All right, so it checks out. All right, let's take a look. Next, we have this solution, this equation, and then this equation. All right, negative 3xk minus 4. And we have our x and our y, negative 1, 0, 1, 2. All right, and then our k, x and y, k is 1, 0, 1, and 2. All right, well, in a case like this, we have k is equal to 1, 0, 1, or 2. So in order to verify, we're going to need to do this, complete this table to see which of these would match, okay? So let's take a look. Negative 3, negative 1, minus 4. This would be a negative 4 minus 4 gives us a negative 8, okay? All right. Negative 3, 0, minus 4. This would give us 0 minus 4. This is negative 4. Okay, negative 3, 1 minus 4. This would be negative 3 minus 4 would give us a negative 7. Right? And then if we have a 2, all right, negative 3, 2 minus 4. This would be negative 6 minus 4 would give us negative 10. Okay, so we keep going up in value. Okay, let's see. Let's see what would happen if we go ahead and make these equal. Let's do it that way. 3, because we'll be a while trying to guess how this is going to work out. Okay, so then let's move our k so that we have 2k over here, 3k over here, positive, and we have 3k over here, so that negative 4 is equal to 4k. Divide both sides by negative 4, by negative 4. Divide both sides by 4. Moving this over here. That would be negative 1. This would be k. Alright, so then negative 1 seems to be our solution. And that seems to be a problem for me. Let's see what the text has to say about it. The text says it's negative 1. But when I plug in negative 1, I don't know if I agree with it. Let's see. Negative 3, negative 1 minus 4 equals negative 1. This would be a 4 minus 4, negative 4. No, that would be a 4. Negative times a negative gives you a positive. All right, I need to think on this to see what's going on, okay? Don't quite agree with it, but it says negative 1 is the case, all right? And so I'll come back to that, all right? Sorry about that. Let's take a look at number 6, okay? Number 6, if we make it equal, then we would move, and this would be negative 2z equal to 2. Divide both by negative 2. Z is equal to a 1, a negative 1, okay? So that would be our solution, okay? Negative 1, that would Z would be equal to. And if we use a table, table would be for our 6z and then our 8z plus 2, x and y, In this case, if x is negative 1, this is negative 6. If x is 0, this is 0. This is 1, x is 6. Okay? Here, negative 1, 0, 1. All right? If 8 times negative 1 plus 2 will give us negative 8 plus 2 will give us a negative 6. All right? We have a match. If we had 8 and 0 plus 2, we'll have a 2. And then if we have an 8 plus 1 plus 2 is 8 plus 2, we have a 10. So our match is negative 1. Okay? All right, so we did a table and we checked. Okay? All right, let's go ahead and check it with doing our equation. 3 minus 4q equals 2q minus 21. Okay? Let's both sides equal. So we're going to add a 4q, add a 4q. And 3 is going to be equal to 6q minus 21. Then we're going to move the 21 over, plus 21 is going to give us a 24 equals 6q. Divide both sides by 6. and we have 4 is equal to Q. All right, 4 is equal to Q. All right, so let's check. Two equations. This equation, 3 minus, oh man, too long. Let's keep going. 3 minus 4Q equals, we have an X and a Y here. So when X is 1, 2, 3, and 4, okay? So that, let's work with it. 3 minus 4 times 1, that's 3 minus 4 will give us a negative 1. Okay, 3 minus 4 times 2, that's 3 minus 6 will give us a negative 3. Then 3 minus 4 times 3, that's 3 minus 12, give us a negative 9. And then 3 minus 4 times 4, that gives us 3 minus 16 will give us a negative 13. Okay? All right, so now let's take a look at our next table. Our next table is 2Q minus 21. All right, let's go with our X and our Y. We're going 1, 2, 3, and 4. Okay, so that when, we need some working space here, we're going to use this spot here. When 2 times 1 minus 21, we have 2 minus 21, and that's going to give us a negative 19. All right. We have 2 times 2 minus 21, that's 4 minus 21, and that is going to give us a 17, negative. Then we have 2, 3 minus 21, that's a 6, minus 21 gives us a negative 15. And then 2 times 4 minus 21, that gives us an 8 minus 21, that gives us a negative 13. And so we have a match. We have a match here, we have a match here. All right, one more here. Let's make it equal first. All right, by isolating our W, we're going to move our 5 here. So we have negative 7W plus 20 equals 3W. We're going to move our 7 here. So that 20 is equal to 10W. We're going to divide both sides by 10, and W is equal to 10. 2. 20 divided by 10 is 2. Okay? All right. So then 2 is our match. Well, let's double check that. Okay? We're going to use some space. You can't see that space over here. We're going to use some space up here. Okay? For our table. How about that? In fact, we'll just do this. Okay, so we have this equation, and then we have this equation. Okay, so that negative 7W plus 15, X and Y. Remembering the X represents a variable that you don't know. Okay, since 2 is our number, we're going to go with negative 1, 0, 1, and 2. Okay, and let's just go 0, 1, and 2. All right, here we go. If negative 7 times 0 plus 15, that would just give us 15. Negative 7 times 1 plus 15, that's going to give us negative 7 plus 15 is going to give us an 8. All right, and then a negative 7 times 2 plus 15, that's going to give us a negative 14 plus 15 will give us a 1. All right, so now let's take a look at our next one. Here we have 3W minus 5, X plus X or Y, 0, 1, and 2. All right. When 3 is times 0 minus 5, that's going to give us minus 5, negative 5. And then we have 3 times 1 minus 5, that gives us 3 minus 5, give us a negative 2. And then we have 3 times 2 minus 5, that's going to give us a 6 minus 5, is going to give us a 1. We have a match. Okay. Now, we verified each of those 2 different ways. Okay. Now let's take a look up here. We were given a graph. This is where this line met 3, 2. They want us to verify. Let me read the instructions. Use the graph to solve the equation. Check your solution. If we're going to use the graph to solve the equation, and this is where they cross, then we discover that this is our x, this is our y, and this is what we will use in the equation to verify that it is truly a match. So then we will rewrite 2 times 3 minus 4. Okay, that's for this equation. Then we would do this equation. 2 times 3 is 6 minus 4 will give us a 2. For this equation, negative 3 times 3 plus 11, we plugged in 3 for our x. That gives us a negative 9 plus 11. And we discovered that the difference between negative 9 and 11 is 2. So yes, we have a match. Okay? Now, last problem. You buy 5 shirts and your friend buys 8 shirts. Okay? You spend $48 on shoes. Okay? You both spend the same amount of money. All the shirts cost the same amount. Use a table to find the cost of each shirt. Okay, now we're going to do this. They gave us 3 pieces of information. They say you buy 5 shirts. Okay, but they didn't tell us the cost of each shirt. All right. Your friend buys 8 shirts. Didn't tell us the cost of the shirts. And you spend $48. All right. And you both spent the same amount. Okay. So your 5 shirts plus your $40 is equal to her shirts. Okay. And so therefore they want you to find out the cost of each of the shirts. All right. In order to do that, we make them equal. And so let's go for it. Minus 5x minus 5x. 48 is equal to 3x. Divide both sides by 3. And you will discover that 16 is equal to x. All right. Well, now we want to check that. Okay. We can check that using a table, or we can use a graph. Bottom line, though, is that we can, if we use a table, you have your x and your y. If you were to use a graph, you would plot the points and show where they connect. I have a phone call. I need to stop here, but that is your answer. Thank you.